So let's take a look at some of the ideas here that we have from the past. So in your units of concentration packet, I want to go back to the dilution point and kind of look at how we used to do this versus kind of a new shortcut way of doing dilution. So in question number 9, we had you draw a picture of the solution that you had made yesterday or 2 days ago with the sugar solution. And what I've got here are some little kind of V-shaped things. Just as a reminder, those V-shaped things are a shorthand for is dissolved in water. So here we've got some things dissolved in water. I chose to use 2 particles to represent the particles of sugar that I had in there. My solution happened to have a concentration of 0.0449 molar. Yours is probably close, but maybe not exact, depending on how big of a scoop we decided to take. The scenario here is to take all of this, pour it into here, this bigger flask, add water, and then figure out what the molarity is going to be of this new solution. Obviously, it's going to be less than the molarity it had before because we have fewer moles per liter because the solution is more dilute. In your first year chemistry class, essentially the way we taught you to do this was to take the volume and the molarity of the solution that you started with. So I have 0.250 liters, and there's 0.0449 moles in 1 liter. So the way I've got this set up right now that's how many moles of sugar are going to be in there. Now, in all likelihood, you probably didn't calculate it in that way. You probably turned back a couple of pages in your thing. You looked at how many moles of sugar you had calculated were in your flask, and you swiped it from there. But if all you had was this little picture, you'd be forced to go through that kind of a calculation. So that's the number of moles that's in here. But since we picked this up and poured it into the bigger one, the only sugar that's in the bigger one is the sugar that was in the littler one. So we moved it all over to here. So in the 750 milliliter flask, we have 0.0112 moles of sugar. And now I ask the question, what would the molarity be after we moved it to the flask and added water to get it up to 750 milliliters? Well, we know how many moles we have. Let's assume that this is 750 point, because up here it was 750 point. So we know how many moles we have. We know how many liters we have. 0.0112 divided by 0.750. And so the molarity of our new solution, once we've diluted it, is 0.0149 molarity. And that's how we taught you to handle this situation the first time you came through chemistry, was basically find out how many moles you have, take that number of moles and divide by your diluted volume. There actually is a shortcut to doing this that we don't introduce to people in our first year chemistry classes. The reason we don't introduce it is that when we show people this equation, then they go around trying to wildly apply this equation to every possible scenario. And so we find that it's easier to just never introduce the situation at all. But there is a very quick way of doing this that's often used in the medical field because time is kind of at a premium when you're making the calculations. On the flip side of the page here is a new equation. This equation right here is called the dilution equation. And the equation itself is C1V1 equals C2V2. This is actually how nurses and pharmacists go about doing dilution calculations because it's just so much faster, and because these concentrations can be any unit of concentration. This works with molarity. This also works with all 3 of the percent solutions. So it speeds up the process quite a bit to just use the dilution equation. If I try to apply this to the situation that we just had, I had to bring forward my concentration of my sugar water. You've probably got a different number because yours didn't necessarily match mine. So the scenario just described was I take 250 milliliters of a 0.0449 molar solution, I dilute it to 750 milliliters, and I want to know what the new concentration is. To use this, I just plug these numbers into the dilution equation and do algebra. So we have 0.0449 molar. And I can just use the volumes as long as the units match on both of them. 250 milliliters is equal to the new concentration when I get done diluting it, times 750 milliliters. Now to solve it, I can divide both sides by 750 milliliters. That makes that part cancel. And now I've just got to do the math. 0.0449 times 250 divided by 750. And C2 ends up being 0.0150 molarity, which if I compare it to what I got back here, it is essentially the same number. This one's 0.0149 as opposed to 0.0150 because we had some intermediate rounding on the previous one. But it's a quick way to get exactly the same answer. And this is how I'm going to encourage you to start doing dilution problems, because this is a chemistry class kind of geared toward getting people ready to enter the medical field. It makes sense to have you start doing this kind of according to the standard that's used in the medical field. So here's another example of the whole thing. And sometimes people find it kind of useful to draw a picture of what's got to happen here in the end. I think people get lost in the words. So let's draw a picture of what needs to happen here. So I need to end up with (500 milliliters) of a 5% mass volume solution of glucose. That's the goal. My problem is I have a bottle. Let's see if we can draw a bottle here. I have a bottle that contains 25% mass volume of the glucose. What I need to do is I need to pick up this bottle. I need to pour some amount of this into here, and then add water. And when I get all done with the pick up and pour and add water operation, this needs to have a total volume of 500 milliliters and have a concentration of 5%. The real question here is, when I pick up and pour, how many milliliters shall I pour out of that bottle such that when I add the water, I end up at 500 milliliters right at the moment that that's got a 5% concentration. That's my initial set of conditions. This is my final set of conditions. These are all the 2's. These are all the 1's. So my problem here is how many milliliters to use. Or in other words, find V1. That's the unknown piece at this point in time. how much of that solution shall I use? Well, let's start filling in the rest of the parts. Initially, this is a 25% mass volume solution. I'm just going to leave it with the percents at this point and stop tracking these things along. In the end, I desire it to be 5.0%. And my new volume of this stuff needs to be 500 milliliters. I'm going to use my dilution equation, C1V1 equals C2V2. I'll put all the parts and pieces in. 25% times, I don't know how much to use, is equal to 5.0% times, I want to have 500 milliliters when all is said and done. So we'll divide both sides by the 25%. Do the math. 5 times 500, divide by 25. V1, I'm going to use 100 milliliters. If I have to express that with only two significant figures, I'm going to have to do 1.0 times 10 to the second milliliters. Or what you will sometimes see people do is just underline this 0 to say, this 0 is significant, that one's not. That's an okay way to go about doing it as well. And then you just ask yourself real quick, does this make sense? Could I pour 100 milliliters into here and add water until I had 500 milliliters? Yes, I could do that. If you come back with the answer that I need to pour 1,500 milliliters into here and add water until it's 500 milliliters, that doesn't make sense. You probably want to go back and check your algebra. And then the last one that I want to look at from your packet is figuring out what's the molarity of this new solution. So now we've made this new solution that's a 5% solution, and I'd like to know what the molarity is. So essentially what I've got to do is I've got to get from 5% mass volume to molarity. And I think the easiest way to do this is to simply do it by picture in terms of what does a 5% mass volume solution mean. When I work with percentages, I always think in terms of I've got 100 of whatever it is. Mass volume, what that means is that 5% says I've got 100 milliliters. And of that 100 milliliters, 5 grams of it is glucose. But you could have just as easily thought about using a lot more of this. If you had rathered, you could have thought about all 500 milliliters that you just made. And so think about this up here that was 500 milliliters. If I've got 5 grams in every 100 milliliters, that means if you got 500 milliliters of this, you'd have this scenario. I've got 500 milliliters and 25 grams of glucose in there. Either one of those thought processes work. I favor this one because I just like to get in the habit of thinking about hundreds when I'm going to do this. So I've just got to get from grams per 100 milliliter into moles per liter. Well, the volume's not too bad at all. 100 milliliters is 0.100 liters. Got that part handled. Now I need to do a quick grams to moles conversion. I'll do the blue one, but if you want to do the red one, you certainly could. 5 grams of glucose, which is C6H12O6. Before class started, I actually made that calculation just so we'd have a molar mass. 180.156 grams in a mole of glucose. 5 divided by 180.156. Keeping two significant figures, 0.028 moles. And that 0.028 moles is dissolved in 0.1 liters. So my molarity is 0.028 moles. Or a molarity of 0.28 molar.